Finally, the history of Earth's climate attests to planetary self-control. NASA, the National Aeronautics and Space Administration of the United States, when they were designing a spacecraft for landing on Mars, asked James Lovelock, a noted British atmospheric chemist, to evaluate the evidence for life in the solar system. From such considerations, he developed the Gaia hypothesis, that life on Earth has served as an active control system that stabilizes the physical environment and the chemical composition of the planet. Some of the extensions of this hypothesis have reached theological proportions. This harkens back to a belief common in many human cultures that constancy in the natural world is guaranteed, if not by divine providence, then by the balance of nature. Does the history of Earth's climate support this view? Has Mother Nature ever lost control? The temperature reconstructions presented in these video segments do not provide a definitive answer. Our planet has oscillated back and forth a dozen times from thick ice sheets covering the majority of the surface to little or no permanent ice anywhere. Temperature regulation, if it does exist, seems to be within broad limits, on the order of 10 degrees Celsius. Yet deviations in Earth's climate have never been as extreme as those of neighboring planets, where mean surface temperatures have fluctuated in recent history more than 100 degrees Celsius for Venus and 60 degrees for Mars. The rise and fall of temperatures on Earth, as well as Mars and Venus, are strongly correlated with changes in greenhouse gas concentrations. At times, greenhouse gases served as regulating mechanisms, such as when accumulations of atmospheric CO2 defrosted Snowball Earth 1 and 2, and other times greenhouse gases exacerbated temperature fluctuations, such as the release of methane from the sea floor sediments during the global warming during the Great Dying and Late Pliocene thermal maximum. The next video segments examine the causal relationships between climate and so-called forcing factors, such as greenhouse gases. Changes in climate and biota are dynamically linked. Organisms serve as major sources or sinks of greenhouse gases and therefore have driven climate change. In the reverse direction, climatic shifts, including Snowball Earth, Great Oxidation Event, Ordovician and Silurian extinction, Great Dying, KT boundary, and Late Pliocene thermal maximum, extinguished many existing life forms, but created opportunities for different ones to come forward. Such considerations inspire questions with theological ramifications. To what degree is the dominance of humans on Earth merely happenstance or divine providence? But for a few asteroids, might a dinosaur of another kind be giving this lecture? Alas, the discussion about the interplay of religion and our view of long-term risks awaits other video segments. In summary, global average sea levels are rising rapidly. 2, global average precipitation and storm intensities are increasing. 3, life on Earth has stabilized its physical environment and chemical composition. Lastly, 4, the climate variations on other planets are more extreme than on Earth.